Okay. Hey, I am going to teach Punnett squares today. And so I would like for you to open your genetics packet, and you're going to find this first handout on page 7 that you can see on my screen. It looks like this, and it says Punnett Squares Vocab Review. So this is just a little handout that I initially go over to kind of teach Punnett squares. It's a great resource for you when you're doing some of these problems on your own. If you kind of forget how to do the problems, then you can go back to this resource and use it to help you remember some things. So first of all, remember I told you that the vocabulary was extremely important. This is where it really hits home, because we're going to start doing these genetics problems in these words like dominant, recessive, heterozygous, homozygous, genotype, phenotype. You have to know at this point what these words mean. It's just going to really slow you down and confuse you. So here's just a little review, a vocab review of what these words mean and how we apply them to genetics problems. And then there's also a little review on here of how you complete a Punnett square, which I'm about to teach you. So this is just a good resource. It's in your packet. If you ever, get stuck, this is something that you could pull out just as a little helpful tool. Okay. So now if you go to page 8, there are some blanks there of some squares that you're going to be doing some practice Punnett squares along with me. So I'm going to pull up a screen here where we're going to practice some of these things. And so I want you to do exactly as I do. On my screen, I want you to do them on your paper. So the first Punnett square that I want to do with you is I want to show you the cross that Mendel did initially with tall plants and short plants. And so when he first crossed his pea plants, he took a tall plant and a short plant and he crossed them. So this is what actually happened, although he didn't know the letters, the particular genotype of his plants. This is what he had. He had a purebred tall and a purebred short. So he actually had a homozygous dominant and a homozygous recessive plant crossing. And when you complete a Punnett square, you have to first know the alleles of the parents, okay, the parent plants. And remember, the alleles are the combination that they have for that particular trait. Okay, so just as a little review here, if the trait that we're talking about is height, okay, then remember that the alleles, they get one from each parent. Okay, one from each parent. So for Mendel, the genotype of his initial cross was big T by little t. So big T was one parent and little t was another. So when I go to put these on my Punnett square, you can see here that I take the one and I split it up. I just put one T here and one T here and the other one here. So you always use the left side of the Punnett square and then the top. And it doesn't matter which parent, male or female, that you put on the left or the top. It could be interchangeable. And then what you do is you just kind of follow a pattern where you start with the top left here, and you're going to just kind of pull this letter and this letter over and that letter down, and you make it big T, little t. And then you go and do this one. You're going to do the same thing, pull over and down, and that's big T, little t. And then you're going to pull this big T over and then this little t down, big T, little t. That big T over and this T down, again, big T, little t. So that's how you do a Punnett square. We're going to do several practice, but you follow that pattern to kind of populate your squares, okay? And then what you do once you see this, you analyze it. And you analyze it by looking at the different possible phenotypes and genotypes. So remember, a Punnett square predicts the probability of offspring. So this doesn't mean that this parent plant is going to have 4, parent, offspring or little plants. This just means for every single offspring they have, each offspring has the chance of these 4 combinations. Okay, so hopefully that's kind of clear. So let's look at our genotypes first. And I want you to notice this is an easy one because there's only one possible letter combination. You'll notice that they are all big T, little t. So I'm going to put big T, little t here. And we're going to attach a percent probability to this. So this is easy. It's 4 out of 4. That's 100%. All right, so what does this mean physically? So what does the trait physically look like? So we're looking at tallness or height in plants. And so remember that tall is dominant and short is recessive. So in this scenario, every single possible outcome carries a dominant allele. Remember what a dominant allele does. It dominates other alleles or it takes over. So that means that every single one of these plants will be tall. 100%. Okay, so let's try what Mendel did next. So remember, this perplexed him. He thought that the plants would be medium. They were all tall. So he decided to take two of his F1 generation and cross them. So let's set up that scenario. So he's got one that's big T, little t, and then he's got another one that is big T, little t. We're going to follow the same pattern, big T, big T. Now this is interesting because you would think you would write it like this. But if there is a dominant allele present, then what you do is you actually will write it first. Okay, so we're actually going to write it like that. Over and down, big T, little t. Over and down, little t, little t. Now, we've got a little bit more variation here. So let's look at our genotype first. So we have big T, big T. Okay, so I'm just going to put that down first. We have big T, little t. And then we have little t, little t. Okay, so how probable is it for each of these to happen? Well, how often did big T occur? Yep, it occurred 25% of the time. Big T, little t, 2 out of 4, which is 50%. And then little t, 1 out of 4, which is 25%. Note your percentages should always add up to 100. So what does this plant look like as far as its physical trait or its phenotype? Is it tall or is it short? Well, if it has at least one dominant allele, it's going to follow the dominant trait, which is tall. So that means that this plant is tall, this plant is tall, and this plant is tall. So we have the possibility of tall, and that's going to be 3 out of 4. This plant is short. So that's going to be 1 out of 4 or 25%. And again, those percentages should add up to 100. So that's what Mendel did in his first two crosses. Let's try some more. Hopefully you would be able to tell from this next one that I'm going to show you that this would be pretty self-explanatory, but let's just say, hypothetically, that Mendel crossed two short plants. What would be the outcome? Well, their genotypes are little t, little t, little t, little t. So are you going to have anything other than little t for the offspring? No, you would not. So this would be 100% short and 100% little t, little t. I just wanted to show that to you. I think that probably you could have done that one in your head, but I just wanted to point that out. And what about this scenario? What if you had a tall plant that was this kind of tall and a tall plant that was this tall? So one was homozygous dominant tall and the other one was heterozygous tall. What would that mean for the offspring? So if I complete this cross, okay, note that every single plant is going to be tall because they all have the tall dominant trait. And for our genotype, you have this kind of genotype and this kind of genotype at 50%. Then you have this genotype and this genotype at 50%. So it's important to note that the percentages for genotype and the percentages for phenotype are not always the same for the outcome. So don't just assume that it's the same. You actually have to do the work. So this is just a little intro. I want to do one more possibility for you and show you how two brown-eyed parents can actually have a blue-eyed child. So this is true. Brown eyes is dominant to blue eyes. But if you have parents that are both heterozygous for brown eyes, which means that they both have one dominant allele and one recessive allele, can they have a blue-eyed child? And the answer is yes. So these are my brown-eyed parents, and see, watch what happens. If we look at our outcome here, okay, this child is little b. So this means that every time these parents have offspring, the offspring has a 25% chance of having blue eyes. So this may be, your genetics. You may have blue eyes with brown-eyed parents and think, where did I come from? Well, it is possible. It is possible. And it just depends on if the parents are carriers of a recessive allele or not. So what we're going to do is continue to practice these problems. I have lots of practice for you, and we're going to do some together. I'll give you some time to work on them with other people, come together. I've got lots of little activities. And so it starts in your packet, starting on page 9, where it says Punnett Square Practice. So if everyone would go to that page, and I'm going to end the video, and we're going to start practicing some of these problems.